Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 10, Chapter 4, The Stages of Development, Discrete Activities, Part 1. Recently, a customer asked us to add a new interface into the system for one of the subsystems that they had deployed to the field. When extending a system in this way, knowing what part of the code to change, where to add code that is similar to other parts of the system that do the same sort of thing, is crucial to adding a capability in a way that will be supportable in the future. But in this case, there was no design documentation for that part of the system. Actually, there's no design documentation for any part of the system except for the parts that we had developed. The other developers that the customer had hired hadn't written any documentation whatsoever. None. Design and design documentation has two purposes. First, during initial development, it provides an intellectual tool for thinking through the solution to the problem, how to make the system behave in a desired way. Second, during maintenance, it guides the engineer to the correct part of the system where changes need to be made, or shows how a similar problem has been solved so that all similar problems are solved in the same way. Lacking documentation, the developer has to read as much of the code as needed to find the presumed part of the code that does the work, and based on that single data point, the code they are looking at, assume that the way that problem was solved is the way that all similar problems are solved in the rest of the system. Not highly likely. If the only documentation is the code itself, then it needs to be the best code ever written. The best. Unfortunately for us, the code was crappy, obviously suffering from a lack of design. It wasn't that the design wasn't documented, it just wasn't designed. No design was done at all, so there was nothing to document. When there's no or limited relevant information, then the code keeps growing according to the tribal knowledge of the developer working on the system at that moment. A developer who may or may not have been around during the initial development of the system. And if they hadn't been a part of the original development team, then they have to read a lot of code to figure out what is happening and where. The design also guides the system integration and certain levels of software test and quality assurance, system and integration testing to be specific. These are levels of test that verify the quality of the system, where the behavior or function of the system that is visible to the end user is only suggestive of any problem. These are the parts of the system that are put in place to support scalability, among other things. Not something the user will ever observe directly, and will only notice when the performance has started to suck so badly that they cannot help but notice it. One system I observed had such a poorly designed query for retrieving data about fielded systems that the entire feature it supported was utterly unusable. It hadn't started that way. Early performance was acceptable, but as the dataset grew, performance started to suffer. The growth in the dataset was not anticipated, was not even thought about. The developer was not wholly to blame here. The customer, I'm looking at you, SaaS founders, was so parsimonious that they encouraged, almost demanded, that shortcuts be taken and necessary process steps forsaken to save money. You want it bad? You get it bad. In the interest of quick and cheap development, the design step is often skipped or given short shrift. Contractors hired to produce a SaaS MVP are constantly under pressure to build a system quickly and cheaply. Such systems are usually little better than working prototypes, which are highly useful as proofs of concept or requirements elicitation tools. However, prototypes should be scrapped as soon as those purposes, proof of concept, and requirements elicitation, have been realized. But they never are. They're kept around as the core, the guts of the system. As time grinds on and maintenance, bug fixes, and addition of new features promised to users and customers, accretes more and more code to the rotting guts of a rickety prototype, development bogs down, and the current set of developers start murmuring about the need for, quote, refactoring the code, close quote. Often, code refactoring fails to back up and create a design for the existing system. The process may not include a design for the desired, more easily maintained system either, so there can be no gap analysis that identifies how to efficiently and effectively refactor or re-engineer the code. Refactoring, pursued as a new round of code and fix hacking, merely perpetuates, perhaps exacerbates, the problem. Agile methods can be highly useful in creating software within the context of an overall system design. That context includes the constraints imposed by the overall system design, the plan of the overall structure of the code, the set of stated requirements, and the business analysis of the problem being solved. All the valuable information about the system contributes to guiding the solution. What I'm trying to do here is paint a picture looking backward from a deployed supported system and argue for some level of process and documentation so that there is a prayer for the system to continue to be supported long term. We are impaled on the horns of a dilemma though. If it takes too long or costs too much to develop in the first place, then we run out of time or money and the thing never gets done. If we cut too many corners during initial development and spend no time on the activities and documentation of business analysis, requirement specification, analysis, and design, both high-level and detailed, then the system will not be readily supported once deployed. A buggy MVP, once it is deployed, either needs to be maintained somehow or replaced with a bug-compatible, re-engineered system that can be maintained. Note that something can be re-engineered only if it has been engineered in the first place. For the long term, the product, not the customer segment, must be taken from an immature prototypical solution to an engineered product. This is maturing the solution, moving from a troubled childhood into adolescence, with luck, not juvenile delinquency, and hopefully into productive adulthood. I call this crossing the swamp. This usually entails hiring a CTO or technical expert to facilitate the transition to maturity. That transition would be less painful and much less costly if some basic engineering steps had happened during initial development. Hindsight is 20/20, but other projects' hindsight can guide the foresight of new projects. Depending on the SDLC employed, these activities may occur at different times and be conducted by different people or roles. Developers may not call these by these names. Heck, they might not even know they are doing them, but each is done more or less on every software project. It is better to do these things mindfully rather than implicitly and ad hoc. But if the function of the leader is to share their vision with people and encourage them to pursue that vision, then why is it important to know this level of detail? The British Navy was renowned for developing their commanders from the bottom, and I mean bottom, up. Starting as a cabin boy and working their way up through the ranks, the hopefuls learned each and every facet of the sailing ships. The process was no respecter of nobility. Everybody started at the bottom. Eventually, if they received a command, they knew every sail and sheet, forward and aft. The idea was that the leader should know the capabilities of their vessel, and when asking the crew to do something, the leader needs to know that it can be done and what it means for it to be done correctly. The discrete activities are also called disciplines, which fits well with the British Navy analogy. The early on, life cycle-wise, activities will likely use models to describe and analyze their subject matter. These models, at least the most important ones, should be documented and the documents maintained and controlled. Business analysis. The goal of this discipline is to understand the business of the organization and the problem domain being addressed by the project. It also seeks to identify a viable solution to address the problem. The business analysis effort produces a variety of artifacts. These may include user acceptance tests, a description of the automation opportunities, business process models, sets of business rules, a domain model, perhaps in the form of business use cases, an organization model, and a project glossary. The glossary can benefit developers with no experience in the problem domain. That ends Chapter 4, Stages of Development. Discrete Activities, Part 1. Join us next time for Episode 11, Part 2 of Chapter 4. Remember, you can always cut to the chase and purchase the book in your preferred format. See the show notes for the link. That's it for me, for you, for now. Be careful out there. Bye.